Hello and welcome to the FCICA webinar series. Thank you for joining us. This webinar will be recorded and housed on FCICA's educational portal. All attendees will receive a follow-up email with the recording within 24 hours. Audio for today's event will be broadcast through your computer speakers. Be sure they are turned on and the volume turned up. All participants have been placed on mute. If at any time you would like to ask a question, please use the question feature. Only the staff will see your questions. And an announcement to our SIM attendees. If you have attended this live webinar, one CEU will be entered on your behalf, provided full attendance. Please note the system records your attendance time and participation level. No CEU will be granted if the minimum level of engagement is not reached. A few announcements about upcoming events and webinars. Save the date for the 2025 CFI FCICA Convention, rebranded as the Unified Flooring Expo. 2025 is the third year our organizations have joined together to produce this event. It will take place in Nashville, Tennessee, September 16 through the 18th. We also have a great lineup of educational webinars coming up. Thursday, May 15, time of install moisture testing for concrete slabs. On Thursday, June 5 is avoiding the risks of concrete moisture. And on Thursday, June 19 is the multi-purpose thin set mortar myth. We encourage your attendance and engagement with FCICA via these educational opportunities. This list of webinars will be included in the post-webinar follow-up email, or you can visit fcica.com under events, where you will find the full list of webinars. We encourage you to register today. The link to the events is also in the chat box. Thank you for joining us today for the Secrets of Substrate Perfection, Measure, Level, and Verify. We are pleased to introduce our speaker, Aaron Abbott. Aaron is the Senior Technical Product Manager for LATICRETE International. Aaron has extensive experience and expertise in the building materials industry, and he is a trusted authority in substrate preparation and flooring systems who works closely with architects, specifiers, contractors, and building owners, both domestically and internationally. In his role at LATICRETE, he leads product and application technology initiatives, provides education and outreach, and ensures customers achieve flawless flooring projects. Welcome, Aaron. I'm going to turn the controls over to you.
Okay, thank you very much, Christine, and thanks to FCICA and all of the FCICA members and the attendees of these webinars. Thanks for hosting this webinar series. I know that I have learned a lot from coming on these things and just listening to colleagues in the industry talk about their areas of expertise. So it's really good. And the conventions and the annual or biannual meetings, really good. So thank you, Christine and FCICA. So today we're going to be talking about some more substrate preparation. I mean, if you've been on other webinars with FCICA or other organizations, you've probably heard about the importance of substrate preparation. I know that LATICRETE certainly has a lot of educational information out there about substrate prep, and it's an important subject. And today we're going to be focusing particularly on one of the several criteria for substrate perfection, or one of the several areas that you have to concern yourself with, and that's flatness. And we're specifically going to be talking about measuring it, verifying it, and even using this to make sure that we're meeting all of our flooring manufacturers' guidelines for flatness. So, when installing any kind of flooring, we all know as flooring professionals that flatness is important. And where does flatness sort of, fit within the other substrate prep areas? So flatness is really important. That's what we're going to be talking about today. But just stepping back for a second, the other things that are often talked about and are certainly, as important, cleanliness of the substrate. That floor needs to be clean. You can't have debris, etc., on it, obviously, when you're putting down your floor covering. Deflection of the substrate, deflection and strength of that, and solidity of that structural floor, that slab, or could be wood, etc. That deflection and strength, very important. Moisture and the environmental conditions inside the area where the floor covering is going to go down, of course, that's very important. I know that working with some of our friends in the flooring manufacturing industry, especially, for example, companies that make resilient products that are intended to go into hospitals, for example, or other demanding areas, that moisture is very, very key, and even in the environment inside the building prior to the installation, very important. And the surface condition, are we talking about a nice flat new concrete floor or a renovated floor? All of these things are important. But again, today we're going to be talking about very specifically flatness and some, and I'll get into a specific piece of equipment or category of equipment, a digital altimeter that can be used to measure elevations at various points on the floor, and how to do an elevation survey, how to mark it, how to use that for doing something like patching or self-leveling to remedy flatness problems that are pre-existing. So that's what this is going to be about, but I'm going to start with a little background on flatness. So the big picture on flatness, I guess one thing that I would start with is that flatness might be in the eye of the beholder. If you're installing a bowling alley surface, it's going to have very specific, maybe bowling league mandated flatness criteria, right? There's probably also criteria about the hardness of the wood and all sorts of things. And so flatness is application specific. If you're building a bowling alley, you're going to, probably require a different level of substrate flatness than you would if you are installing shag carpet in a bedroom, in a residence, right? But in all cases, flat and smooth helps the flooring, no matter what you're talking about. You want flat, you want smooth, and it can be new or a renovation that we're talking about here. So in general, sort of a roadmap to think about when you're thinking about flatness in the context of substrate prep. There's some pretty simple, things that you have to think about, and I'll just present these as sort of general criteria that you should always be thinking about when you're thinking about flatness and flooring installation. So the very first thing, clarify the flatness requirements. And that can come from a variety of sources. It could come from the manufacturer of the flooring, or in like the bowling alley example, it could come from maybe bowling league standards of flatness. But it also could come from industry groups like ASTM, or it could come from the flooring manufacturer's instructions. It's good to start from what the flooring manufacturers and what the context requires for flatness, and pull those instructions, get them up front, pin them to your wall, put them in your some of your first meetings about how you're going to execute a project. And then the next thing is to start thinking about the space that the flooring is going to go into. So inspecting the floor and making plans for how we're going to verify flatness, how we're going to verify what the substrate is starting with. When we're installing flooring, we're installing it on a pre-existing, concrete slab or a wood subfloor, or possibly even pre-existing flooring from the prior use of the space, right? So we want to inspect that floor, get a feel for what we're starting with, and then plan for where we're going with what we need to install the new flooring and provide the flatness, etc. Obviously, this is a good time to look at the other aspects that we touched on earlier too, for substrate prep, like moisture, for example. So then, oftentimes you are benefited from doing a survey of the floor. So if you're thinking about flatness and you want to know, is my floor level? You may use a level. You may use a straight edge. You may use a laser level or a digital altimeter, like I'm going to be talking about in a bit. So that survey can be used to sort of see a whole bunch of things. Most importantly, how much preparation material is going to be required to level and flatten the floor. So if you have a floor with a bunch of craters, or a floor that's at a tilt, at an angle, and you want it to be flat, this is where you're sort of calculating the elevations versus level, and you're coming up with a estimate of substrate preparation materials like patching materials, skim coating materials, self-leveling maybe, or other types of fill that's going to level that floor out. And then if you're using self-leveling, for example, or patching materials, it's often very helpful to mark the floor and use indicators like pins, elevation pins or level pegs. There's a lot of different types of names for these things. I'll show you them in a bit. And then as you're performing the installation of the patching or self-leveling, you can actually check your results as you go to try to make sure that you're doing it right the first time. Once you're done, there can be some more verification, and then you install the flooring. And even after you've installed the flooring, it's possible that the owner or the general contractor who's hired you is going to want to do another verification step. So back to how flat do we need? So again, different flooring products have different requirements. And speaking of concrete, if you're talking about a concrete slab, especially if it's elevated, but it can be slab on grade as well, you need to think upfront about these questions. Who defines flat in your context for your project? Who is defining flat? When is it measured? How is it measured? Usually these things are spelled out, and if you don't know, find out, because this is important. And one important thing to keep in mind too is that concrete flatness, if you're talking about a new building especially, concrete flatness can change over time. Deflection can be present. Can it be predictable? Who is responsible for that? So one place that talks about flatness, one standard is ASTM F710. So this relates to installing resilient floor coverings over concrete substrates. That's what it's primarily focused on. So that's really one of the starting places. And if you then want to go back to, say, the floor covering that you're going to be installing, and you're reviewing their installation instructions, they might have a product data sheet, they might have an installation guideline. Different manufacturers have different documents, but they're all generally available on their website. So find those and look at their recommendations. In a lot of cases, the manufacturer's recommendations, or even an industry group like FCICA or NFCA in Canada, they might publish recommendations of their own for flooring. And a lot of these reference ASTM F710. So F710 is one that you'll see a lot. ASTM F710 specifically, again, this is called the standard practice for preparing concrete floors to receive resilient flooring. This talks about a bunch of things, but in terms of flatness, it has this section 4.5, which says that the surface of concrete floors shall be flat to within the equivalent of 3/16 inch in 10 feet. And it talks about a method to do that gap in 10-foot measurement. Or they say you could use any industry recognized method specified. And they also talk about an equivalent of 1/32 of an inch in 12 inches. So that's another way, a shorter straight edge to look at. So that's in F710. And again, often concrete is poured on an elevated deck, and those concrete contractors are going to measure using one type of method. And then when you come back and you're ready to install flooring, you're actually going to be using a different method. You're going to be using sort of the FF measurements for concrete. That's what they use. And they use that within the first 72 hours, I believe, of pouring the concrete to meet their contractual obligations. And then when it's time to install the floor covering, now we have this ASTM F710 3/16 in 10-foot requirement, right? So those two methods are different. And this photo shows on the right side and lower side, sort of the darker structural concrete that's been cleaned and prepared. And then there's like a self-leveling layer that's been poured in one big long strip. And you can kind of see where the concrete may seem level, but it's not. You can kind of see a thin area up near the top. So that's sort of the difference between the concrete meeting its initial flatness requirements, and by the time you need to bring in your self-leveler, it's actually not. So just a quick review on those measurements. F numbers, so floor flatness, which is usually talked about and specified in Division 3. That is defined in ACI 117, and ACI 302 talks about the guidelines for placing and finishing, and ASTM E1155 is the actual method for determining F numbers. It's a device that kind of sits on the floor, rolls over the floor, is slid over the floor, and it gives you a statistical number. I think between something like 0 and 100 are the numbers I typically see. I think it could potentially go higher, but and this contrasts against the straight edge method, which the floor covering installer might be more familiar with and might use more often, which is basically putting a 10-foot straight edge down on the surface and looking for daylight underneath, and you're allowed up to 3/16 inch gap in 10 feet, according to ASTM F710. Again, your specific flooring might have a tighter standard, like the bowling alley is probably going to require less than 3/16 in 10, a tighter standard. Other floor covering might require tighter than that. 1/8 in 10 is very common when you're talking about certain types of flooring. ASTM F710 also talks about smoothness, so that there's not irregularities that telegraph through the new resilient flooring. And that's so that's measured right before the installation, and the F numbers are measured by the concrete contractor within 72 hours of the concrete being poured. So there can be a big gap in time between these two. In the tile industry, it is more and more common to be installing very large format tiles. And just looking at this photo, I think you can appreciate the need for flatness. If you have even a little bit of waviness, where one end of that large tile is higher than the other, it's going to crack, right? I mean, so you got to be very flat for flooring like this, like these large format tiles. And just a brief note about the correlation between, say 3/16 in 10 or 1/4 inch in 10 and the FF number. Even though experts will say they don't really have a strong correlation or a definite correlation, sort of a rule of thumb might look like this. So on the up and down axis on this chart, so a 1/4 inch in 10, if you follow that line over, that meets up with about an FF of 25. Okay, so if you're hearing that your floor is FF 25, that rule of thumb is that's going to be equivalent to a 1/4 inch in 10 feet straight edge. An FF of 50, which you might hear about for hospital hallways, hospitals in general, they want very flat floors. So the specifications might call for FF 50 in that construction, and that roughly correlates to a 1/8 in 10. And one more point about new concrete. Okay, so various organizations, including the American Society of Concrete Contractors, the National Wood Flooring Association, the Masonry Institute, Tile Contractors, and FCICA was a sponsor of this paper, which is called Division 3 versus Division 9 floor flatness tolerance. And this is an important point that they make that relates to flatness, which is basically that what I was just talking about is that Division 3, which are sort of the concrete specifications, they measure FF, and Division 9 flooring specs talk about straight edge gap, and that these two measurements aren't compatible, in part because there's a bunch of time between when they're taken, and floor flatness can change to a whole bunch of different things that happen, right, with concrete: curling, deflection, settling. So what this paper says basically is that when a new building is built, they recommend that the owner provide a bid allowance. Providing this allowance allows the owner to compare the floor covering bids on an equal basis. They're basically saying, assume that your concrete is going to move and change, and if you're thinking upfront, even before the concrete contractor bids are in place, that you're not going to be able probably to maintain a flat enough floor that it's going to be flat enough that you can just install floor covering directly over it. In a lot of cases, especially for things like hospitals, projects like hospitals, it's just not possible to build elevated slabs that are going to, predictably stay within that, say, 1/8 inch and 10 foot gap tolerance. So this is, and what we're seeing, what I'm seeing personally, working with contractors and projects, is that there's more and more pre-construction meetings where these questions are faced before the project begins, and everybody's brought to the table: the concrete contractor, the floor covering installer, if self-leveling is going to be used, the self-leveling manufacturer, the glue manufacturer, if that's someone different. All of these different people, they talk through what's going to be required for the flooring, what's going to be required for the concrete, what's going to be required for the amount of time that takes place between these things, and what will have to be remeasured and adjusted. And if you do this up front, there won't be surprises. And this is really we're seeing it starting to happen more and more, where there's more upfront thinking about these changes that are almost guaranteed to happen. So surface prep, again, many different things. You like we said earlier, we need clean, sound, solid. Got to be free of stuff that looks like this picture, right? You can't just put sheet vinyl down over something like this. You got to clean it. And so one of the methods that is very common is the abrasion, mechanical abrasion. This photo is of shot blasting. Can this flatten the floor by itself? So if you're starting with concrete, can you assume that your mechanical abrasion is going to be able to achieve the flatness requirement? So first of all, think about these methods. They can be scraping, chipping, grinding, shot blasting. There's things like hydro and water jet blasting as well. And then acid etching chemical, that's really not going to change the flatness at all. That would be more for cleaning, and those you have to be very careful with those. But so for this mechanical abrasion, can you achieve flatness just by doing this? Well, maybe with, shot, or I would say grinding, diamond grinding. If you have some high spots on concrete, you might be able to, grind those down. Shot blasting is not going to generally do it, and usually grinding by itself is probably not going to get you to exactly where you need to go, fully either. So keep in mind that these techniques are mostly used to prepare the concrete to be able to hold down a good bond with a skim coat or a patch or a self leveler that's then going to be able to do the heavy lifting for you and get your flatness requirement, right? And you also may be doing this mechanical abrasion for putting down primers or moisture mitigation systems. There's a whole bunch of reasons to do this. It's to get the floor clean, get the concrete open. But generally, my point here is that usually this isn't sufficient by itself to get the floor to the flatness requirement that your flooring is actually going to need, okay? So the elevation survey, this is something that is a little bit different. It's not a direct measurement of either gap in 10 feet, like this doesn't necessarily directly measure a gap in 10, like a 1/4 inch in 10 or whatever, and it also doesn't directly measure FF. But this is something that can be used. The elevation survey basically is looking point by point, usually in a grid, on the surface of the floor that you're about to put your floor covering down. And what this allows you to do is get a few things. One is you want to get an accurate estimate of material requirements. So if you're say you're going to, that you have a floor that's wavy, out of level, and it needs to be leveled, and it needs to be smoothed. So doing this type of survey before you start can give you the most accurate estimate of material requirements. So if you accurately can estimate, how much material you need to fill from what's existing up to where you want the top of your new self-leveling underlayment to end up, you have, you have a good budget. You have a predictable expense that you can go forward with in your project and do a good bid, hopefully a very competitive bid. A lot of people do this before they bid. And this also allows you to communicate with your client potentially about the status of their floor. They may tell you, oh, the floor is flat, you can just put your flooring down. Have you ever heard that before? Doing the elevation survey can actually create a map, a heat map, like what's on here on the bottom right, that shows sort of the topography of the floor, almost like mountain ranges and places where lakes would be, versus the zero. The zero is where you want the top of your actual substrate to be, the substrate that's going to be placed by pouring the self-leveler, right? And this process enables highly flat floors. So even though I said that this technique is not a direct measurement necessarily of gap in 10 feet or FF measurements, this is a additional way to assure quality. And you definitely, if you're using this type of technique, this system, you're going to be able to meet any requirement that is commercially present out there right now. Any kind of 1/8 in 10 or even greater than that, you can get very high floor flatness by following this method. So the survey can be done by different pieces of equipment. What's shown here is a digital altimeter. Another word for this or term for this is a water level. There's actually not water in most of these. This one that's shown here is called the NIVCOM, but there's other commercially available devices as well. And laser levelers also can do sort of the same thing. They might present the information a little differently, but they can do the same type of thing with some minor changes. So the concept here, especially if you're using self-leveling to level your floor, it's sort of a three-step process. You're using the survey device to take measurements versus a zero, right? So you're going to establish your 0 point as the height or the elevation of where you want the top of your self-leveling to be everywhere. And then often you'll be marking the floor or marking or keeping a note of the location and marking this somehow, either electronically or on paper, on a drawing, so that then you can map it out and display this map as one of those heat maps or a topographical map of the floor. That allows you to get your estimate of how much self-leveling you need to purchase and install. But the other aspect of this, you can see the level peg, this elevation pin being cut with scissors. So if you've measured, say, 17 millimeters deep at a certain area versus a 0, some people will mark the floor, others will record it in some other way. In this case, they marked 17. The level peg is cut at 17 millimeters and it's adhered to the floor. And then this is used to be a visual quality control technique that you pour the self-leveling everywhere on the floor, and you're going to have some higher pegs in places where you need a deeper fill, and you're going to have some very short pegs or pins where you have a less shallow requirement because the floor is higher in that area, right? So these kind of just stay in the floor. This technique has been used for at least 20 years, and it's very successful in allowing for very, very high quality flatness of self-leveling. It works especially well for self-leveling. So we're just going to go through some details on this particular unit. Again, I'm just picking the NIVCOM. This is a digital altimeter. Again, it's sort of like a water level. There's a hose that is on a reel and an electronic device that has the altimeter display in it, and it can be set to measure in millimeters or inches or fractions of an inch. But again, this is just one device. There's other devices that are very similar to this on the market, and there's also digital, or I should say, laser levels, which, although they operate on a different principle, they can do the same sort of thing. Basically, the idea is point-by-point elevation measurements. So I'm just going to talk about this one, and some of this would be useful to those of you who have this type of device, but a lot of this will be useful even if you're using a laser level or some other type of device. So this type of unit typically has a reel, which it reels up the hose, and has a fluid reservoir, and it acts as a measurement point of reference. So this is placed somewhere and then it's not moved. You unreel all of the hose, place it on the floor, and then move around the floor with the handheld unit, which senses the changes in height. And this particular unit has a rod, an extension rod, so that you can walk without bending over. And the pole basically hits the surface of the floor. And at that point, you're going to be reading getting your elevation readings. So let's see how this works. So for this unit, you want to place it on a flat, stable surface, right? And you can, for this particular piece of equipment, you can leave the reel in the case or put it directly on the floor. It doesn't matter. It just wherever you put it, you have to assume while you're doing your measurements, you don't want to move that. You want to allow enough hose to come out so that you have plenty of space to work with. Because once you move the reel, you're changing your zero, okay? Because that's going to be the point of reference. So on this device, there's a pressure release knob. You open that up. There's a light that comes on to show you that it's open. And again, you're going to be letting out enough of this hose to measure all of the measuring points on your floor. This NIVCOM device, I think, has a 75-foot hose. So if you put your reel in that case, if you set that in the middle of that area, that you have about a 150-foot diameter area to be doing your elevation measurements. So this device is, we like this one, it's very simple, has one button, okay, that does all the functions. Single press turns it on. You allow the unit to sort of stabilize. There's some indicators that will flatten out when it's stable. You're going to wait for the zero to appear, and you're going to click the button, okay? And the position that you're in, where you're holding this unit, when you zero it, you want to, again, zero it physically at a place on the floor that you want the top of your future self-leveling to be. In other words, this is going to be where the substrate is, that 0 point, okay? And then when you go and you do your measurements, they should all be negative. They should all be below that 0 point, and that's how it's going to show up. With this device, you want to be kind of careful. It's measuring pressure and converting that to height. So it's like an altimeter in an airplane, except it's the liquid inside the hose reel and the hose going all the way up to the unit where the pressure sensor is, where the actual altimeter is. That sort of magnifies air pressure, right? You can't just do this with air pressure. You need something to sort of magnify it. So the liquid helps to magnify that. So you zero and you move your measuring device to the new location. And you're going to be seeing on the screen a indication of how many millimeters or fractions of an inch it is from where you're measuring now to up to that zero location, okay? If you're above the zero, you're going to see a indicator that shows you're above it by having an arrow that points downwards. You can actually change this on this device to plus or minus if you prefer that. So back down at zero, it's good to recheck your zero now and then to make sure you haven't moved the hose reel inadvertently. And the zero indicates that that's your reference point. You can turn this unit off by one long press on that single button. So those are the basics for this. And shutting it off, very simple. Just close that pressure reel valve. All right, now let's talk about how to use this with elevation pins or level pegs. So I've seen all sorts of different things be used to try to indicate level on floors when self-leveling is going to be used. I've seen people drill holes and insert drinking straws into the hole, and then they cut them to height. That's one way to do it. You can drive screws or hammer nails into the floor at the desired height so that the top is at your zero. There's Z-shaped pieces of metal that are commercially available. So there's a bunch of different things. There's these little tripods that you can use, I've seen also. But one thing that we really like is these elevation pins. So there's different versions of these that are commercially available, level pegs, elevation pins. So these are basically specially engineered pieces of, like, they're tabs with an adhesive on the bottom that can be cut to specific heights. And they're usually, a few inches long. to start with. So when you're using these with the NIVCOM, I think it should be obvious that as you're, if you're doing your survey and you're finding, let's say, what is 1 inch? About 24 millimeters. If your floor is or your concrete is depressed about 1 inch below your where you want the top of your self-leveling to be, you're going to see a lot of pegs around that 24 millimeters. By the way, these pegs can also be in inches, not just millimeters. But a lot of customers who are using these, a lot of installers that are using this type of system, they tend to prefer millimeters after a while. It's just easier math, I guess. So one thing you want to look for is really good adhesive on the bottom of these should be peel and stick, and they should be able to stick to the concrete or primed concrete, should be able to stick to wood, and the plastic itself should be a spring back type of plastic, because once you've installed these, there's still going to be some trade traffic, and sometimes boots will step on them, or if you're pumping self-leveling, the hose might go over these things, slide over them. So you want that adhesive to be good enough to hold it down, and you want the plastic to not just be your everyday polyethylene. It should be a rubberized, engineered plastic to spring back up straight. So here's one example, which I'll go through pretty quickly here, of how you could plan out an elevation survey. So here's sort of an L-shaped room where you don't have full line of sight. So this is an instance where the NIVCOM type of device, the water level type of device, would be preferable over a laser level, because you don't necessarily have line of sight. And these digital altimeters, you can zero in one corner and then go around another corner or even into other rooms and still maintain your zero. You don't have to have line of sight back to the laser, okay? So steps here to do the survey and install self-leveling. That's going to be perfectly flat because you're using an elevation survey and elevation pins. So you plan out the grid. So how far spaced should these points be? For traditional floor flatness tolerance, maybe like 1/4 foot and 10 feet, maybe 5 to 10 feet. That's where the elevation pins should be placed. So more exacting, maybe 3 to 4 or 5 feet if you're talking about 1/8 in 10. Okay, so tighter spacing for better or tighter floor tolerance. Plan to place more pins in critical height areas like door jambs to make sure that you've got really good accuracy. Certainly, like at an elevator sill, you want to make real sure that you're watching your elevations. So you'll do your reference height. This can be a spot like a sill, or it can be something that you measure off of a existing item like a sill or an edge of the wall. It's often marked with a screw. You'll screw something down into the concrete, and the top of that will be the zero. But it needs to be a physical place, and you need to zero on that, okay? And then you go to your first grid point. These grids can be pre-marked, or they can be, chalk lined out. However it works for you. There's a whole bunch of ways to do that. But you go to your first grid point, get the depth measurement, and this is going to be the pour depth at that location, right? So we're going to take one of the elevation pins, cut it at that height. In this case, it's 38 millimeters below the zero. So we place that pin there. And then we follow that, right, until the entire floor is gridded, okay? And there could be 2 steps to this. You could do a survey where you're just doing measurement, but you're not pinning it yet. You're just doing the measurement to estimate the quantity of material, or even just to do the survey so you can show your customer how bad their floor is. But when you're doing this for self-leveling, for example, you're going to be cutting those pins, and you can see on this diagram that the pins are at different heights. The lower areas in the floor have longer pins, the higher areas have shorter pins. But at the end of the day, each one of those pins is exactly or within a couple millimeters accuracy of the system to it's very close to that 0. So the top of each one of these pins is now at exactly the 0 point for where you want your floor to be. And this is sort of what this looks like in practice. You'll see a gridded out area. The pins are placed. This customer is actually placing the pins first and all of them and then cutting them. I think they're using actually a laser level and chalk lines maybe to cut the pins, but you can do it directly with a digital altimeter and cut out that step too. There's different ways to do it. So then when the floor is poured, right, you're going to be using the pins as a visual guide, and it's extraordinarily helpful to the crew that is putting down self-leveling to be able to know that when they reach the top of these pins, that's when they stop, right? That's when the pouring stops, and you're right at that level. You want to just cover them, and they remain encapsulated in that floor. So here's what that looks like. This is a picture of a very deep fill. I think the elevation pins that they're showing here are actually extended with little blocks of wood. They could have bought longer pins, but I guess that's what they had in this case. So that's how it's done. They're using this as a measuring guide, as an on-site quality control technique to be able to get right up to the top of those pins, and then with pretty good confidence that your floor is going to be flat. So I am stopping a little bit early here, and I'd like to hand it back over to Christine and anybody that has any questions. And I think I'll leave this on the photo. That's better than the thank you screen.
Thank you, Aaron. If anybody has any questions, please enter them in the question feature now. The following is a two-parter. One is a question, and then the second part is a statement. I'm going to read that question, Aaron.
Okay.
Is the language between the differences between Division 3 and Division 9 going to be implemented into F710?
Okay, so I believe F710 does talk about both sets of measurements. I believe it talks about floor flatness in an appendix. So it definitely does recognize the difference. And I think the point that F710 makes is that different groups, or different interests, whether you're a concrete contractor or whether you're a floor covering installer, you've traditionally been using different types. So it recognizes that, and it also recognizes that, currently the traditional method of measuring flatness for floor covering installers is still the 10-foot straight edge. So I guess it does recognize it, but it doesn't unify it yet. And that's a good question as to whether or not someday maybe it will be unified so that there's just one system for both. I've heard things, but it's not done yet.
The second part is a statement, so sort of statement question. Since FF is measured shortly after the concrete is set, and we don't get in until much later, those numbers no longer matter. You want to comment on that?
Yep, that's an awesome point. And we live that every day, right? As floor covering installers, as contractors, as manufacturers of self-leveling, et cetera, et cetera. Everybody in our FCICA group, we all know about this. We felt it. And the point that I would make is just keep getting the message out that this is the case, that FF is something that's measured within 72 hours of concrete. And by the time we are, as flooring professionals, we're getting in on there. It could be 6 months later. It could be a lot later. And we're going to be asked to use probably a different type of measuring system, and an allowance should be made for patching or self-leveling in the initial bid package. And the smarter GCs, or I should say the more forward-looking, educated general contractors who are building towers, for example, are aware of this, and they're starting to bring all the parties together, and they're starting to, make it more of an even playing field. And not, the worst thing is to be surprised at the last minute, right? Like somebody saying, hey, the floor is flat enough to install flooring, or dry enough for that matter, right? But we're talking about flatness here. But where there's misunderstanding, that's where finger pointing can happen, and delays. So hopefully we just get the word across, and that's one of the good things about FCICA. Where these types of webinars, these types of get-togethers and information sharing, it helps us, helps all of us. So thank you for that question, statement.
Thank you. Thank you, Daniel, for that. He adds another comment on the same topic or the same question. How do we convince architects that this needs to happen? If this language is in F710, it's in all the architect's documents from the start.
Great question. Education, I think, and so I know that from my standpoint and LATICRETE's standpoint, we have, and our competitors have the same thing, educational opportunities. We do AIA presentations. We do, LATICRETE has its own sort of educational system, online system called LATICRETE University. Our competitors have similar things like that as well. These are very useful for getting the message out. And architects they have to continue. Architects sometimes don't want to worry about the means and methods. They don't want to think too much about, how something is done when there's multiple methods. But really the important community to get, so architects can help here, and education can help, but I think the most important community that'll help us as floor covering professionals is actually the general contractors or the construction managers of the world. And, hopefully they're members of FCICA also. I'm not sure about membership breakdown. Christine, do we have a lot of GCs, national GCs that are attending? But that would be great, because it's really them that are going to be hurt most by delays in the project. What's the most important thing for a general contractor who's building a tower? It's the date of handover, right? The occupancy date. They're looking at that, and the cost, of course. And they're one of the things that's going to screw them up every time is, you get to install the flooring, which is usually towards the end of the project. And just, at that point, you find out the floor is not flat enough, and we didn't think we needed anything. Or, this also goes for moisture mitigation as another point. So good point, but I think architects and general contractors or construction managers need to be the targets of the educational reach out.
Next question. It's a question and then also sort of an impression. How soon after a new concrete pour can the initial flatness test be done by the concrete contractor? And then Russell states, my impression is that it is done sooner than it should be, and that the concrete can still change after that test.
Absolutely true. It can change after the test, and the test is written. So the test was developed, the FF test, the floor flatness test. I think it was developed for really the concrete contractors' interests and the interests of helping them be able to measure the quality of the flatness of their concrete pour, right? and it's to allow them to get paid for their work. So it has to be done, in that light, it has to be done relatively early. And the way that it is written is within 72 hours. So, that's what the method says. And that's the official method right now, is that it needs to be done within the first 72 hours. And so I think they understand that what can happen later is outside of their control. And again, the message that I think we, as in the floor covering industry, are, we're left with having to continually talk about this, try to spread the word, is that the concrete will deflect. The FF is really just to get the concrete contractor paid. He did his job. He did everything he can do. He can't be expected to predict deflection, maybe, I think is the idea, 6 months down the road, because there's so many different factors leading to deflection or curling, etc. I mean, from the structural integrity of the steel skeleton, maybe, just for example, curing conditions, all sorts of variables play into that. The point that we need to keep talking about is FF is really useful for getting the concrete contractor paid, that he did his thing, okay? And then assume that all bets are off the table. That's what we have to do for now, until some better methods are out there for predicting concrete deflection and curling, etc. They're just not there now. So what we need to assume is that it will change, and it will have to be remedied somehow. Skim coating, patching, self-leveling, some form, or mechanical abrasion in some cases too. Some form of remediation and surface prep.
Next question. You refer to flatness. Is that the same as level?
No, nope. Flatness is the, within one plane, basically how, like, think about a table. A table can be flat, but I can lift one half of the table up 6 inches and now it's not level. So level is analogous to sea level. It's reference to, the level of the ocean when it's completely calm. And, gravity helps that. And flatness is basically the, how planar the surface is. So think about the rectangular table. It's flat and level when it's, when all 4 legs are doing their normal thing. But if you lift 2 of the legs up 6 inches, it's still flat, but it's not level any longer. So you do have, and so FF, we talked about FF. FF is floor flatness, FL is floor level. Both of those things are often measured by the concrete contractor. We didn't talk too much about level directly here, or FL in this presentation, but that is different, and it is important too.
Next question. What's the difference between a laser level and the NIVCOM type levels?
So the laser levels are usually configured with like a tripod that has on top of it a rotating laser. It's set at a specific level. It rotates and the laser beam comes out at a flat lighthouse-like circular motion, and it's pointing outwards at a flat and level point in all directions. And then the second part of that would be a device that looks like a yardstick, essentially a tall yardstick, which you can walk around on the floor with, and you can then see where the laser hits it. And by adjusting the that device, you can get heights versus that 0 that you've set. So it's and the NIVCOM is just directly measuring elevation on a point on the floor by direct contact with the bottom of the pole, basically. So both laser levels and the NIVCOM type devices, they're giving the same end result. You know, you can get how many millimeters are you below a 0 point. They both can do that. The laser level is needs line of sight. It's shining out a laser beam, so you can't go around walls, right? Once you set it up. The NIVCOM, because it's a hose, it can go into other rooms and you don't need line of sight. So those are the differences and similarities.
Thank you, Aaron. There's one more question, and that is, when should I use a self-leveling versus skim coating to flatten the substrate?
Yeah, good question. So skim coating or patching is generally for either smaller areas like craters or small depressions that need to be filled where the rest of the floor is measured as flat enough for the application. And self-leveling, you know, good rule of thumb, if you're looking to build up a height across the entire floor, it's self-leveling materials are definitely very easy to use across large areas. They're going to somewhat seek their own level. They need to be persuaded, usually by a smoother or a gauge rake or something. But so, you know, if you're building up more than, say, 1/4 of an inch everywhere, I would say, or even in much more than 1/8 of an inch everywhere, self-leveler might make more sense. But if it's spot fixes or partial areas in each room by room that need to be smoothed or filled, that's when patches and skim coats are more useful.
Okay, thank you so much, Aaron. That is the last of the questions that have come through. Any final statements, Aaron, for the group?
I would just say thank you, Christine and FCICA, and thanks to all the FCICA members as well as, you know, attendees that might not be members. Hopefully, if you're not, you will be soon. I learn a lot from these webinars myself. I like to go on as many as I can and hear other people's perspectives. And I really appreciate the membership, especially the group meetings are great to just talk amongst ourselves. So it's a constant learning experience. I really love to learn. And so thanks to everybody.
Thanks for the shout out, Aaron. And thank you everybody for attending. Just a few last minute reminders that attendees will receive a go-to email with the recording of this webinar within 24 hours. And again, just as a reminder, the link to the event listings is in the chat, and you can click on that now to be directed to the website to register for future webinars. And again, thank you everybody, and thank you, Aaron, for presenting. We appreciate it, and enjoy the rest of your day.
Have a great day, Christine and everybody.
Thanks, Aaron. Bye-bye now.
Bye-bye.